All right, so we're going to continue with chapter 8, but now we're going to be looking at using radical expressions as opposed to rational expressions. So you'll notice when you read these two slides here, we're going to be dealing with what? Radicals. So we're always going to have that radical symbol in these couple of lessons, okay? Now, the one that you're the most familiar with, has an index of what number? No. Number. 2. All right, because that would mean it is a square root. Most people have worked with square roots a lot at this point. All right? But the reason that you guys were confused when I said what number are you used to is because if I write this, is that a square root? No. Yes, it is. If I don't write any index, then it's assumed to be a square root. So if you ever write a radical with a 2, I'll tell you that's redundant. You don't need to write that 2. Okay? Make sense? All right. So anytime it's not a square root, if it's a cube root, fourth root, fifth root, sixth root, whatever it is, then you need to put whatever that number is in the index. So that is the index. All right? The plural is indices. That's fun, right? Indelesia? Indices. All right. So these properties here, all right, again, you don't have to memorize the names. These properties you've already seen with doing radicals in Algebra 1, as well as looking at exponents. So these should look very similar when we get to doing the examples. So let's try an example here. All right, the reason this is a little different is because it is a cube root. All right, so the way that I teach kids to do this is to first deal with the number. So let's deal with the cube root of 27. So again, anytime you have a radical, it's asking for what value raised to this index gives you the number inside, which is called the radicand. Radicand. Okay, so I'll say it again. What value raised to this power gives you 27? 3. All right? Do you guys know that that's what a radical means? Yeah. Some students know how to do all this stuff. They don't actually know what the radical is asking. All right? The reason I bring that up is because it's going to get more challenging when I throw in variables. Okay, so here we go. Let's look at the cube root of x to the 6th power. This time, when I say it, instead of not writing anything down, I'm going to write something down. All right, so some value raised to the 3rd power needs to give me x to the 6th power. All right, so what should go in here? Whatever that is, that's going to be my answer. All right, and so from the rewind, if I put x squared, a power to a power, what do I do with those? Multiply to get that. All right, so that's why the cube root of x to the 6th is x squared. Is everyone good with that? Yeah. Now that you know that, from now on, if these are divisible, go ahead and divide them, and you'll get what the exponent is remaining. Bless you. So what is 6 divided by 3? 2. It's 2. So from now on, you can just do that, as opposed to this. But know that that's what you're doing. All right? Yeah. Now, it's going to get difficult when this and this don't divide evenly. Great. And that'll be in the practice. Okay? Exactly. So let's do another example. It says to simplify the cube root of x cubed over 7. All right, now we're going to use one of those properties from a few slides ago. Do you see how this fraction, it's inside the entire radical? I'm going to split it up. All right, I'm going to put one radical with x cubed and one radical with 7. All right, you are allowed to do that. And you can go the other way, right? If I had it like this, I could put it all together. All right, the reason I do that is because you should see the numerator. I can take the cube root of x cubed. What is the cube root of x cubed? X to the 1st power, right? 3 divided by 3 is 1. So we have x to the 1st power over the cube root of 7. Now that is the answer. But why is it not the answer?
Because you can't have a radical.
Yeah. Very good. Okay, we cannot have a radical in the denominator. So that means we need to do what? Do you guys remember what that's called? By this, right? What is that called? It's called rationalizing the denominator. Rationalizing the denominator. All right? So you did this on the rewind. All right, so we're going to multiply by what? 7? Just 7? No, not 7. The square root of 7?
3 times.
That's not a square root. The cube root of 7 over the cube root of 7. Now watch this. Am I done?
No.
Why not?
You have to multiply.
Well, actually, I'm not. I can't multiply yet. Because if I did multiply, 7 times 7 is 49. And is there a cube root of 49? Yes, there is, but it's a decimal. So I have 2 of these. Well, what is the index? So how many do you think I need? I need another one. So now when I look at the denominator, what is 7 times 7 times 7? Oh my gosh, you're using the calculator, Guillermo. Very nice.
343.
343. And what is the cube root of 343? Really don't need the calculator. It should be 7. Right? Because if I do the cube root of 7 cubed, just like I did before, what's 3 divided by 3? So that's why it's 7 to the first power. If you're confused, whatever this index is, I need that many in the bottom. Okay? And so notice, in the top now, I still have x. Right? I still have x. But what's going to happen with these up here? What's 7 times 7? So I'm going to write times the cube root of 49. And that is simplified. Let me go. Oh, because I split this radical into 2 separate ones. And the cube root of x cubed is x. Yeah. So the answer here is this. Now, again, is that any different than what I started with?
No.
No, but that one over there doesn't have a radical in the bottom, so that's simplified. Because if I do this 7 times 7 times 7, that's 3 7s, right? So 7 cubed, and the cube root of 7 cubed is just 7. All right, again, once you get the number that you want that's in the index, right? If this was to the 4th root, right? If it was the 4th root, I need what? Another 7. All right, another 4th root of 7. So you need the number that's in the index.